so here it is. Consider the differential equation, the following differential equation, okay? And there it is. It's dy over dx equals 2x minus y, all right? First question is A. Let me see if I can. A. It's not very thick. Go a bit thicker on those. There, that's better. It's still not that great. I'm going to go here. Whoa, that's way too thick. Sorry, guys. This is, there we go. We'll do that one. All right, we'll leave it at that. Okay. So on the axis provided, sketch the slope field for the given differential equation at the 6 points indicated. So here they are, 6 points. 2, 1, -1 are my y coordinates. And I got 0 and 1 for my x coordinates. Okay. So I'm just going to make like a chart here, right? X and y. And it looks like I've got x coordinates of 0, 0, and 0. And I've got y coordinates, or x coordinates of 1, 1, and 1. And then they each have their corresponding y coordinates. So I've got one for 0, -1, right? So 0, -1, 0, 1, 0, 2, and then I've got 0, let's see, I've got 1, -1, 1, and 2 as well, all right? So that's what we're looking at there, okay? Question is, how do I figure out the slope? Well, this is it. dy dx is the slope. So I just take these values, 0, I plug it into here, and then -1, I plug it into y, and I get my slope. So 0 minus a -1 is a 1. So I'm going to write dy dx is 1. Okay, like that. All right. Now, here, when x is 0, y is 1. So I'm getting a negative slope, -1 slope. When x is 0, y is 2. So I'm getting a -2 slope. So for all of these ones, for 0, -1, I got a slope of 1, which is something like that. For 0, 1, I got a slope of -1, which would be something like that. For 0, 2, I got a slope of -2, which would be something like that. So you want to just kind of make a general slope thing there. Now I do the same thing here. So 2 minus, so I'm getting a slope of 3 here, right? Because I just plug my 1 in for x, and I plug my -1 in for y. So there it is. I'm getting a 3. Plug my 1 in for x and my 1 in for y. So 2 minus 1, what's 2 minus 1? Is going to be a 1. And then it's going to be, I plug my 1 in here and my 2 in for y. So 1, so 2 minus 2, oh, I'm getting a 0. Okay. So at 1, 2, so 1, 2, I've got a slope of 0. At 1, 1, I have a slope of 1. And let's see, what else do we have here? 1, -1, I got a slope of 3. So it's a pretty steep slope. There it is. That one's done. All right, that's part A. Okay. Let's go with part B. All right, shall we? So I'm going to move down. I'll take this guy with me. Oh, I lost my slopes up there, but that's okay. Here we go. Find d2y over dx2. So this is basically, you're asking you to find the second derivative here, okay? So this is part B. Find the second derivative. Well, I know that dy dx is 2x minus y. So if I just apply another derivative to this, right, another derivative to this side, then I'm basically finding my second derivative now. All right. Keep writing an x there, but it's supposed to be a y. There we go. So this is dy dx times dy dx. So that's just dy dx squared, written as this, or the second derivative here. This derivative distributes into over this entire function. The derivative of 2x is 2. The derivative of y with respect to x is dy dx. How's that? That's pretty cool. And we got it. But wait, dy dx is 2x minus y. So my second derivative is 2 minus dy dx, or 2x minus y. All right. They also want us to do this, is determine the concavity of all the solution curves for the given differential equation in quadrant 2 here. Okay. Now, basically, they're asking you to find the concavity of all of the general solutions, or specific, all the general solutions. And they want us to focus on quadrant 2, okay, which would be this quadrant. Now, in that quadrant, x is less than 0 and y is greater than 0. So what I'm going to do is I'm going to look at this, and I'm going to kind of stick these guys in here. And I'm going to say 2 minus 2, x is less than 0. So it's going to be some kind of negative number, right? Minus some kind of positive number, right? So 2, this is a negative 2. So that's going to end up being a positive. So it's actually just going to equal 2 plus some positive number, and then plus another positive number, right? So, because this negative distributes into here, making this, right? So my dy dx, which remember, my second derivative, this is my second derivative here, it always tells my concavity. So what's 2 plus a positive number plus another positive number? This is positive, or this is greater than 0, right? And so in justification, give the reason for your answer, we would probably have to write down something like that. In Q2, d2 dy dx2 is greater than 0 for all values of x and y. Okay, here's my justification. So therefore, I would, the question is what's the concavity? I forgot to answer the actual question. So it's concave up. All right. Man, if I hadn't written concave up, I would have missed a point on the AP exam or something there. Okay. Ooh. All right. So there's B. That one's done. Moving down. I'm going to do part C. Let y equal this function and be the particular solution to the differential equation. Let y equal f of x with the initial condition f of 2 equals 3. All right. So basically what they're telling us here for part C is that when y equals 2, x equals 3. I think that's what we've got, right? No, sorry, the other way around. When x equals 2, y equals 3. All right. So we got that. Question is, what do we want to do? Does f have a relative minimum or a relative maximum, or neither at x equals 2? Well, look at this. They give us x equals 2. How do I find maximums and minimums? I have to know if the derivative, or the dy dx, if it's equal to 0. That's my question, right? So, well, dy dx is 2x minus y, or 2x minus y. Well, they give us x. X is 2, and y is 3. There it is. So this is 4 minus 3, or 1. Aha. So dy dx is not equal to 0 at, I guess we could make our point, 2 comma 3. So therefore, it is neither a maximum, so no max or min at that point. Or you can even just write 2 comma 3. Pretty cool. So there's my justification. Remember, you got to justify, right? So my justification is that I've written here. So if I stop here and I just write no max, you might not get some points here. So neither. You just write neither. Some students would just maybe write neither right here, or neither, depending on how you want to say that. Because, but if you don't write any of this stuff down here, you're getting pretty skimpy on your justification. So you want to get your justification going there. All right, so there's that one. Let's do part D, shall we? Part D. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Okay. So they're actually giving us the answer here. They're telling us the answer is y equals mx plus b. That's pretty cool. That's the solution. Now, they want us to find the m and the b. So, you know, m's going to be something and b is going to be something. Whatever, like going to be a 4 and a -1. All right. So 4 equals -1. Now, if I have this equation, y equals 4x minus 1, and that needs to be the solution to this differential equation. Okay. So question is, how do I solve this guy? Well, they're giving me this. So I'm going to take the derivative of this and I'm going to write it down. So dy dx is simply just, I guess, m. All right. Well, that's funny. All right. So dy dx is actually just m. Okay. But dy dx is actually also equal to 2x minus y. That's right. dy dx is 2x minus y. Okay. So this is what I'm looking at. But wait, y is also mx plus b. Ah, interesting. So I'm going to be able to write this. So m equals 2x minus mx plus b. All right. I guess I don't want this equal sign there. Basically, what I'm doing is I'm saying, hey, I just took that y and I got rid of that. There it is. Okay. Ooh. Got my parenthesis. I'm going to distribute my negative sign. I'm going to get m equals 2x minus mx plus b. Okay. And now you're thinking, oh man, I got a lot of stuff going on here. So what are we going to do? What are we going to do? What we want to do here is we want to basically say, look, I'm trying to build a solution that works for all x and all y values. Okay. So basically, if I got something that works for all x and all y values, the x shouldn't matter. So I want to somehow remove this x. I want to remove this x here. How are we going to do that? I'm going to write it like this. I'm going to factor out my x, and I'm going to get x times 2 minus m plus b. Okay. Now, this is the logic here. In order for this to work for all x values, the coefficient in front of this x must be 0. Because if that's the case, then this x would get canceled. And therefore, what that would mean is this m and this b is gonna function regardless of the value of x, regardless of the value of x, because this is the solution for the whole thing. So all x coordinates. So how do I make this x go away? The only way that this x could go away is if m happens to be 2, okay? So therefore, m must be equal to 2. I guess I'll write that out, right? In order for the solution to be valid for all values of x. To be valid for, all values of x. That's my justification here. Because now, if I make m equals 2, so I'm going to let m equal 2. So I'm going to write that 2 equals x times 2 minus 2 plus b. Okay. Oh, sorry guys. I'm sure some of you guys at home caught that. It's supposed to be a negative here because this negative distributes into the b. See that? Okay. So now look at this. So then I get 2 equals, doesn't matter what x is, x times 0 minus b. Well, what's x times 0? Well, it doesn't matter. So that what this means is that x could be anything. Could be 10, it could be 5, it could be million, it could be a zillion. If m is 2, then we're good to go. Okay? So that's what that basically means. And so basically 2 equals negative b, which basically means b equals negative 2. So if we let m equal 2, b equals negative 2. Oops. And in the end, we get it. This is the m and the b that works for this differential equation. And the tricky part is knowing that in order for your solution to work, you want it to work for all values of x. Okay. And let's say you had done something different and you'd end up having a y somewhere in here. You'd have to go through the same reasoning. You'd have to set m or b equal to something such that the y has a coefficient of 0. All right. And that's what you would end up having there. All right. All right. Well, that was pretty fun. I hope you guys liked that one. It was a long one. And yeah, but I think I'll sign off for the evening. Enjoy the rest of your night.